Hello friends, welcome to the video lecture series on digital image processing. I am Dr. Dafda, and in this 79th video class of DIP, we will study steganography in digital image processing and its implementation in MATLAB. I received these comments in few of my videos to make video on LSB based steganography, video on reversible data hiding techniques, etc. So basically, reversible data hiding technique or reversible image hiding technique is nothing but steganography, a technique where the image can be hidden and it can be reversed or recovered at the receiving end. And this steganography is also known as LSB based steganography because we hide the data or image in the least significant bit of the carrier image. So starting with the name, what is the meaning of steganography? Steganography is made up of two words, stegano plus graphy. Stegano is coming from Greek word stegos, which means cover, and graphy is coming from Greek word graphia, which means writing. And therefore, steganography means covered writing or hidden writing or hidden data or image. Hence, steganography is a technique in which secret data is hidden in the carrier image and an intruder on the network can only see the carrier image without realizing that there is a hidden information present in it. Okay, so let us start. For steganography in image processing, we have two images, the carrier image or the cover image and the secret image or secret data. In the carrier image, we hide our secret message or data or image, and this is done typically by modifying the pixels of the carrier image in such a way that it is imperceptible to the human eye. So there are various techniques for encoding data into an image. The first and the most popular one is the LSB substitution, in which we substitute the least significant bit of each pixel in the cover image by the secret image or secret data. And second technique is the spread spectrum technique, which involves spreading the bits of the secret message across the multiple pixels in the cover image, which make it more tough to detection. But of course, it is also very complex to implement. We will understand and implement here least significant bit or LSB based steganography. See, in our 12th video class of bit plane slicing, we understood that an 8-bit image is composed of 8 1-bit planes, with plane 1 containing the LSBs of all the pixels, and these LSBs are the least significant bits that have the least effect on the appearance of the image, and plane 8 contains the MSBs, and this MSBs contains the most significant or highest order information of the image. Also, in our 43rd video class of bit plane coding, we understood that out of the 8-bit planes, we can only use bit plane 5 to bit plane 8 for recovering the image and hence resulting in image compression. That means bit plane 1 or LSB can be replaced or removed without any problem in reconstructing our original image. So if in this bit plane 1 or if in this LSB bit plane we hide the MSB of the secret image, it will not be perceptible to human eye. Now let us understand the steganography algorithm with one example. At the transmitting side, we will do the LSB substitution, and conversely on the receiving side, we will do the LSB extraction. Say for example, our carrier pixel is 80, whose binary is this, and our secret pixel is 200, whose binary is this. So first step is we have to clear the LSB of the carrier. So here our LSB is this 0. So to clear this 0, we will perform AND operation with 254. Why with 254? Because it has got last one as 0 and all others are 1. So if we perform the AND operation, the last bit that we obtain will become 0 if it is 1. Here it is 0, so it remains 0. And all other bits remains as it is. And this we can understand like this, that AND with 1 keeps the bit as it is, but AND with 0 will make the bit as 0. So in next step, we want to extract the MSB of the secret image. So we want to extract this 1. And to extract this one, we will perform AND operation with 128, which has the MSB as 1. So when we perform the AND operation, it will keep this one as it is and make all the other bits 0. So in this way, we extract the MSB. So now we want to add this one, which is extracted, to the LSB of our carrier, which we cannot do directly because it is a whole number. So what we will do, we will divide this with 128. So dividing this with 128 will bring this one to the LSB and we will obtain 1 in the LSB. That is, now what we will do, now we will add this one to our LSB cleared carrier. So by simple binary addition, when we add this one to this, we will get 0 1 0 1 0 0 1, which is our segmented pixel value, and this is 81. So our carrier pixel, which was 80 initially, has now become 81. So the new segmented pixel value is 81, with the LSB modified to embed the bit 1 from the secret image. Now at the receiving end, where we are doing the LSB extraction, we want to extract our LSB How to do that? We'll perform AND operation of this binary with 1. So doing this, the last pixel or the LSB will become 1 and all other will become 0 because we have kept all others zeros. Right? Now this bit we are getting at the LSB, but we know that this is the MSB of the secret image. So what we have to do? We will do the reverse operation of 1 which we did at the transmitting side. So here at the transmitting side we divided it by 128. Here we will multiply it by 128 and we will get 128. So hence we have extracted the bit 1 from the segmented pixel 81 which corresponds to the secret image pixel value. So in this way we can extract all the LSBs and recover our secret image back at the receiving end. I hope it is clear. Now let us implement steganography for grayscale image and color image in MATLAB. Here I am using the inbuilt images cameraman.tif and testpattern1.png. And using this I am replacing the LSB with the MSB, and if we replace more than one bit or if we use two LSBs, then we start getting the watermark, and as we go on increasing the number of LSBs, the watermark gets darker. And see, this watermark is different from steganography. Watermark is used for authentication purpose, whereas steganography is for hiding purpose. Let us run the program and see the output. So this is our carrier image in which we are hiding this secret image, which is test pattern. So our stego image that we will obtain will be like this, and you can see that it is same as the carrier image. But inside this cameraman image, there is this secret image that is not visible over here. When we retrieve from this stego image, our secret image, we get this retrieved image, which is our secret image that is retrieved back. Now let us increase LSB from 1 bit to more than 1 bit. Here I am using 2 LSBs. Let us run the program and see the output. So in the stego image that we obtain, now we can see a very light watermark of the secret image. Let us increase the number of bits to more than 2. So here I am using 3 LSBs for storing my secret image, and running the program, we can clearly see the secret image as the watermark. If we further want to increase the intensity of the watermark, we will use 4 bits. Let us run the program and see the output. So now we can clearly see the secret image in the background. Now let us perform the steganography for the color image. For the color image, there are 3 planes R, G and B, each having 8-bit planes, so we can hide more information. So we extract first the RGB channels from the images, and then we embed the secret image into the carrier image using the algorithm which we just understood in the theory. Let us run the program and see the output. So this is our carrier image in which we hide our secret image, and the segmented image is like this, in which the secret image is not at all visible. When we recover the secret image from the segmented image, we get back our secret image. So that is all for this video class. You can download the PPTs from the Google Drive link that is mentioned in the description box. Also you can download the MATLAB codes from the description box. Thank you very much.